Welcome back, calculus students. Welcome to lesson 8.5. We're going to be talking about area between curves, but now with respect to y. Now, I want to give you a little heads up. If you hear my daughter playing in the background, she's playing with her toys. So, yes, sorry about the extra noise. Now, another thing I want to talk about is I know I said I was going to upload these videos on Wednesday, but guess what? Yesterday was April 1st, so April Fools. I'm uploading these episodes or these videos today. So yeah. All right, let's talk about 8.5. Let's get straight to it. So set up the integral that allows you to find the area in the first quadrant that is bounded above by y equals square root of x and below by y equals x minus 6. So it's literally the same thing what we did in the previous lesson, but now we're doing it with respect to y. So for this, I want to make sure that everything is in terms of x. So like I have y equals. So now instead of saying y equals, I need to make sure it says x equals. So this says y equals square root of x. So I square both sides and I end up with x is equal to y squared. Boom, that's my function. That's my equation I'm going to be using. Next, I have y equals x minus 6. Well, if I want to get x by itself, all I have to do is add plus 6 to both sides. And I'm going to get that x is equal to y plus 6. And that's my second equation, my second function. Now, in the previous lesson, I would bound my integral from 0 to 6. I had to break it up into two parts, remember? From 0 to 6, and now from 6 to 9. This one, my lowest y value is 0. The highest y value is 3. So my integral is going to be bounded between, sorry, I'm getting a little bit of allergies right here, 0 to 3. It's bounded by 0 to 3. I put my equations together. Now, how did I put the equations together? When it was with respect to x, the top one went first and then the bottom one. For respect with y, we start with our right graph first. Right graph first. My right graph comes first. So in this case, my right graph is this one. That's my linear graph. My linear one is y plus 6. So I'm going to put y plus 6 minus y squared dy. And that is your solution. You're setting up the integral. On your calculator, you would still type it in the same way. Math, go to option number 9. You set up your integral from 0 to 3. But instead of putting a y, your calculator doesn't understand y, so you just keep on using the x variable, but you just got to keep in mind that is with respect to y, okay? Let's do the second one. The second one's a little bit more trickier. The reason it's a little more trickier is because you're going to have to get used to adjusting to the graph and thinking about it from top to bottom now, right? So let's look at the second one. The second one here says, set up the integral to find the area bounded between x is equal to 3 minus y squared and x is equal to y plus 1. They're already solved for x, so I don't need to do any of the previous solving. So let's start with the graph on the right side. So let's set up our integral. Our integral runs from, so I have my integral. What's my lowest y value? So I see my graph intersects there. My lowest y value is at -2. So I'm going to go -2. My highest y value is at this point right here, which is 1. So -2 to 1. My right function goes first. My right one, I can see that is this parabola, right? This parabola here. So it's going to be 3 minus y squared minus my first function. My first function is the linear one. So my linear one is going to be minus y plus 1. And again, with respect to y, right? Now, you can simplify these. You can put these together. And the way that I simplify these together is I take the integral from -2 to 1. And I get, let's put everything together. The negative y squared goes first. Then my y term goes next. Minus y plus 2 dy. I literally combined them together. I simplified it, and that was my integral. Now, if you were typing these into your calculator and they're asking you to find the area, it doesn't matter how you type it. You can type in the first one, you'll get the same response. This second one just looks a little bit more neater. And if you're doing an FRQ, it's best to have it as simple as possible. But I'm pretty sure that they would give you credit for both. but I would just play it on the safe side and keep it like this, okay? Let's go on to number 3. Number 3 is a little bit more tougher because now we're setting up 2 sets of integrals. We're setting integrals with respect to x and with respect to y. Now, we have to do things a little bit different for this one. Let's check out our graph first. By the way, we're going to need a lot of space here, so let's write as small as possible and let's be as efficient as possible. I think we're going to need the most space with respect to y. Respect to x is a little bit straightforward, but again, we may need to write small. So let me change colors because the graph is black. So let's see. Let me change color real quick. I think I want to change it from black to red. Let's use red. Testing. Yes, perfect. Okay. What are you doing? Sorry, she can't hide under my chair. But okay. Let's mark all these points. I have this point here on my graph. This is 0, 1, right? 0, 1. This point right here below where it intersects the x-axis or it touches the x-axis is 1, 0. And now I have these 2 other intersections. One point right there and one point right there. The way I get those points, I literally would just have to type all these things into the calculator and then find the intersections. In this case, let's save some time. I know that this first intersection is going to be at 0.5, 1.75. And then this next intersection is going to be 1.36602, that's a 2, sorry, 02, 0.13397. Whoops. Come on. These values are a bit important, so I need to write all of them. Perfect. 97. Okay. Perfect. So make sure you keep all these decimal values. These values are all important. So let's just make sure we have those written down. Okay. So let's start with the respect to x. Everything up here is already set up in terms of y. So all I need to do is make sure I have the appropriate balance. So let's look at with respect to x. With respect to x, the way that we look at it is we go from left to right. We start with the topmost graph. In this case, our topmost graph would be this parabola here, right? Because this parabola takes care of this section right here. The way that I divide this integral is I go from my first starting point to my second intersection point. So that means I'm looking at the area for this chunk here. So this integral with respect to x is going to be divided into 2 integrals, 1 integral and 2 integrals. Okay, so I'm going to erase the 1 and the 2 just so that way you can see it when we do the work. So let's get started. Let's set up our integrals. So let's say we got the first integral bounded from from 0. So we're starting at 0, x equals 0 to 0. What's the point? Can't even speak. What would be the x value at this point here? The x value would be 0.5. So it's bounded between 0 and 0.5. Okay. Now, my integral that goes first, my graph that comes first would be this line, my linear line, right? My lower one would be this parabola. So I got to make sure I identify which one is which. So this linear line is this equation here. So that's going to go first. So that's going to be 3, That's going to be 3 over 2x plus 1. Put it in parentheses. And I'm going to subtract it from this parabola. Because this is the parabola that we're looking at, right? This positive one would have to be this one, the x minus 1 squared. So I'm going to literally write that down. Minus x minus 1 squared with respect to dx, with dx, right? With respect to x. Now, let's look at the at the area for this chunk right here. For that one, so I'm going to go ahead and continue by adding the integral. So I'm going to do a plus. My lower bound, since we're looking at this point here to this point here, what's my x value here? 0.5. So it's 0.5 to 1.36602, right? 1.36602. Those are my top bound. That's my top bound and my lower bound. And in this case, I'm going to go ahead and set up my integral using my equation. So in this case, this one will be the top one. My top one is this negative parabola. In this case, it would be 2 minus x squared minus my lower parabola, which is x minus 1 squared. And then don't forget your dx. And this right here would be your integral with respect to x. That nasty looking thing, that's your integral. So to solve for this, you would need to type that into your calculator. Once you type it into your calculator, you just move on, right? Because you would be able to get that information easily from your calculator. Okay, this next one, with respect to y, this is where things get a little bit more harder because you got to keep up with a lot of different things. First thing you have to do, you want to convert these from being y equals into x equals. So you want to make them all in terms of x, or so you're solving for x. So let's start solving for x for the first one. The first one says y equals 2 minus x squared. So in this case, I pretty much can tell that it's going to be something like x squared is equal to 2 minus y. I pass over the, I square root both sides to get rid of the squared value, square root both sides, and I get that x is equal to plus and minus square root of 2 minus y. The minus y is under the radical, okay? But now, I have the plus and minus. Which one do I use, the positive version or the negative version? Let me erase this line here. So my parabola, my negative parabola, was this one right here. Is this on the positive side of y or on the negative side of y? This is on the positive side of y, right? So I'm not going to use the negative version. So I'm just going to say x is equal to square root of 2 minus y. Perfect. Okay. So I'm just going to use the positive version because the negative version, there's nothing on this side. On the positive side, that's where my graph is. That's where my shaded region is. Okay. Next one. Let's solve for the middle one. For the middle one's a little bit easier. I can say I have plus or minus the square root of y. And again, I did some prior shifting to this. Like you should be able to see where I'm getting that information. So if you look at the middle one, I took the square root on this side and square root on this side. That's why I started off with plus or minus the square root. So I initially just do the first step so that way you can just follow along and I don't write out everything, right? So plus or minus the square root of y is equal to x plus 1. Now, I want to leave everything in terms of x. So I'm going to solve for x by doing a minus 1. So now I get x is equal to plus or minus the square root of y minus, oh snap, I messed up. This one's supposed to be a minus 1. And this is a plus 1 because it's the opposite, plus 1. Notice the plus 1 is outside of the radical. The 1 is not on the inside. Do not make that mistake, please. All right, let's move on to the next part. Let's do it for the linear function. So I have y equals 3 over 2x plus 1. I'm going to go ahead and just shift everything to the right side as much as I can. So let's shift. And I would end up with, what is this? 2y, because the 3 over 2x, I multiply by 2 on both sides. So I get 2y is equal to 3x plus 2. I'm going to do a minus 2, and I'm going to get with 2y minus 2 is equal to 3x. I'm going to divide by 3 on both sides, and I should get 2/3 y minus 2/3, because remember, I have to divide by 3 on everything, is equal to x. So these right here are my functions. These are the functions that I'm going to be using. And again, it's the same thing with this plus or minus square root of y. That's going to be, we're using the positive side, so we're sticking with the positive side. Sorry, I forgot to write that down, but we're sticking with the positive version of it, okay? So now, let's set up our integral. This is where things get fun, okay? So let's start from bottom to top. Let's make our way from top to bottom. So where do we start with our first crossing point? Where do we first intersect? What's our lowest point? Our lowest point is here at 0. So at 0, so my first integral should be from 0 to some value. In this case, my first intersection is here. So this integral is going to break this off into this chunk. The next integral is going to be broken up from this chunk. And then the last integral. So this is going to have 3 integrals. It's going to have 3, 2, and then 1 all the way in the bottom. So it's 3 integrals. Okay. So this one's bounded between 0 and 0.13397. We start from the rightmost side. The rightmost side would be the parabola, the negative parabola. Or in this case, no, hold on. I went from right to left. Yeah, it would be the right one. So it would be, oh no, the positive one, because this positive one is it's more furthest to the right. If you look at this one continues all the way up here, while this one gets cut off here. So yes, I would start with the positive parabola. So I would write square root of y plus 1. Sorry, this is going to be a little bit of a long video, but I'm trying to get it as much as I can and as fast as I can, okay? Minus, parentheses, negative square root of y plus 1 dy. Okay, so let's look at here. If I look at this parabola here, what are you doing, mommy? Hey, you're gonna get stuck. Sorry, give me 1 second, cheese. Move, get out of there, please. Sorry, where was I? So I subtracted the positive version of this parabola with the negative version of this parabola because I lost my train of thought. Blah, blah, blah. Let's look at the graph. I want to find the area for this section here. This section here is bounded between my right side and my, sorry, with the positive parabola and the negative parabola, but I'm not sure why I have it like this. Give me 1 second. It's bounded between this and this. Oh, okay, I see why. So it's bounded between the positive version and the negative version of this one right here. Because if you see, this is where it ends. So like if you look at the positive parabola, it goes up, right? So this part is considered to be part of the positive parabola. But if I want to look at this chunk here, it doesn't really touch anything of this graph, right? It's all bounded at this specific point at the bottom. So that's why I'm restricted to the negative version of that parabola. Okay? So that's why that happened. My apologies if I confused you earlier with what I said, okay? But if, like I said, the negative version would start here. This is all positive in this little chunk. Even at this end point here, it doesn't really get to that negative version right there. Okay? So sorry for my salas moment right here that I had, but let's continue to the next part. Where's my pen? Here we go. Next, don't forget, so it's going to be plus another integral. Mommy, can you put the volume down, please, a little bit? My second integral would be for this chunk here. Now, this chunk here is a little bit more, obvious. Which one's my right? My right would be the negative parabola. My left would be the positive parabola. Noemi, Mama, lower it, please, or can you go to the living room? You're putting it higher. Thank you. So from there, my left bound would be 0. This one, so it would be right here. This is my next bound. So my lower bound would be 0.13397. My upper bound, my next point would be a 1. So a 1, my upper bound of my equation, which would be square root of 2 minus y, parentheses, minus parentheses, my first graph, my positive one, right? So it would be this one right here. This would be my graph, so it'd be minus square root of y. And the reason I'm using the negative version is because I want you to look at the slope. Look at the slope. The slope of this graph, we're decreasing. Okay, so let's focus on the decreasing portion right here. This decreasing portion, so I'm going to use a negative version, right? Because I'm subtracting it. Okay, if I started with, if let's say we were talking about the parabola in terms of being on this side, or like on the right side, then I would use a positive. Okay, let's go over the next one. My next integral, because we already did the second one, let's do the third one. So it's going to be a plus. Don't worry, on your AP exam, you will not see anything like this. If anything, they might just ask you, look at this whole entire thing, and they'll just ask you questions about it, like to fill in the bounds, or like to set them up in terms of like making them, instead of being instead of being in terms of y, make them in terms of x. They might ask you simple things like that, but they will never ask you to solve something like this in the AP exam. I didn't see any examples in your FRQs or in the multiple choice. But if you're able to understand how this is set up, then the rest of the other problems should be a little bit easier. So this one is bounded between 1 and 1.75, because that's my highest y value here. I want to go ahead, look at the right side. The right side is still this negative parabola. So the negative parabola would be square root of 2 minus y. Again, the square root extends to the y. Minus, and in this case, the top part or my left part would be my linear graph, which is minus 2/3 y minus 2/3, right? And then dy. And this whole entire nasty integral would be your setup for with respect to y. Okay. Now, that was a lot to go over. That was a lot to cover. That was just too much information. Hopefully you understood. I would like for you to do the practice problems for at least 1 through 4. Let's see. Hold on. This is 0.6. I want 8.5. Where's 8.5? My apologies, y'all. I'll be a little bit faster in the next video. Yeah, I just want you to focus on 1 through 4. You know what? 1 through 5. Let's just do 1 through 5, and then sketch the graphs by using Desmos. Look at the graphs, try to sketch them using Desmos, and then shade in the region that you're finding the area. You're going to do it with respect to X and with respect to Y, okay? So go ahead, do that, and then I'll see you in the next video, all right? Bye.